Hi, Math 117. Sorry that this is the last video going up, but I'm going to do 5.1 using the z-score chart. So in 5.1, the goals are how to interpret graphs of normal probability distributions and how to find areas under the standard normal curve. Okay, you've seen density curves before. A density curve that is just a curve that is always on or above a horizontal axis and has an area of exactly 1 underneath it. So here is a density curve. Okay, trying to make it pretty symmetrical. You've seen these before. A density curve describes the overall pattern of a distribution. Again, this one looks pretty symmetrical, but you know that they could be skewed as well. The area under the curve and above any interval of values on the horizontal axis is the proportion of all observations that falls in that interval. So if this were perfectly symmetrical, you know that the mean is right in the very middle. 50% of the data falls above the mean and 50% falls below the mean. So that could just translate into 0.5 and 0.5, giving us an area of 1. And then we have normal distributions, okay? Normal distributions are perfectly symmetrical. So these are both perfectly symmetrical. You just notice that this flatter curve has a larger standard deviation than this tighter or more narrow curve. All normal curves are symmetric, single-peaked, and bell-shaped. Any specific normal curve is completely described by mu and sigma. And the way we write this is normal, and then we always write mu first. So if our mu was, let's just say 22, my favorite number, and let's say that the standard deviation is 3. On here, mu would be 22. If we went 1 standard deviation over, that would be 25. I bet all of you probably remember from our 68, 95, 99.7 rule that the area here is 0.34, right? Okay, the standard normal distribution. This is going to be the z-score chart we're going to be using for the rest of the year. But the standard normal distribution has a mean of 0 and a standard deviation of 1. If a variable x has a normal distribution, mu, comma, sigma, with mean mu and standard deviation sigma, then the standardized variable has the normal distribution of 0, 1. That means if you convert into z-scores, you're standardizing it, right? So the distribution will be normal, okay? And that's what we're going to plug into our calculator. So if we convert into z-scores, when we plug into our calculator, that's in my second part of my lecture that's already posted, is 0, 1. Let's go over some examples using the chart. The next video will show you how to use the TI Nspire. So under your resources, I have posted a z-score chart. There are 2 pages, one with positive z-scores, and then on the opposite page, you have negative z-scores. You must remember that all of these give you the area to the left of a particular z-score. So we would just always have to remember that. All right, let's look and see. We want to find how much area is to the left of the z-score 2.13. So that's a positive z-score. That would be out to the right of mu. This is going to be z equals 2.113. So what is this area? Well, we can simply just look at our chart. Let's find where 2.13 is. So 2.1 is here. 2.13 is here, and then we just go all the way into where those meet up to get that the area to the left of that z-score, and that's what we're looking for, is 0.98341. All right. Next, we want to try to find the area to the right of a z-score. So I'm going to draw this. We're going to try to find the area to the right of a negative z-score. So this z-score is to the left of the mean because it's negative. And let's find the area to the right. Let's look on the negative side of our z-score chart. Negative 0.5 is here, and then we've got to go to 0.7 is here and see where those meet up. It looks like right here, but remember that's giving me the area to the left of this z-score. So if I looked on my chart and found that, I can see that that area is 0.28434. Well, then how would I find the area to the right? Well, we could just subtract it from 1 because remember that a density curve always has an area of 1. So 1 minus 0.28434 equals, let me just use my calculator, 1 minus 0.28434. We get 0.71566. So let's go to the very other last possibility, and that's to find the area in between two z-scores. So let me draw my density curve. We have a positive z-score. I'm just going to draw it right here, 1.79. And then we have a negative z-score. And I'm trying to find the area in between the two. Well, what you're going to do is you're going to find the area to the left of both of these and then subtract it. Because if I found the area to the left of 1.79, that would be all of this in yellow. And then if I found the area to the left of negative 1.14, then I would just subtract this part in orange, giving me the area in between both z-scores. So let's look on our chart. What is the area to the left of negative 1.14? So let's see, negative 1.1 right here, and then 4. Looks like the area to the left here is 0.12714. Now let's find the area to the left of 1.79. 1.7 and go all the way over to 0.9. We get that that area is 0.96327, and then we just have to subtract the two. Always subtract the smaller number from the larger number because we would never have a negative z-score. When I do that, let's see what I get. Sorry, the washer is in the background right now. Minus 0.12714. Okay, to get 0.83613. On my next part of the lecture, you can see how to do this on your TI Nspire. Thank you. Bye.